help to show people who don't get to, for whom this is too early or too late, etc. So for people who don't know, I'm Jason Marsh, CEO and founder. Also on the team here is Michael DiBenigno. He's our head of business, and you have probably seen him on TikTok because he rocks that whole format. And if you haven't, check out TikTok, The Data Guy. And Bill Morton is our head of services and training and customer support, and also a fabulous resource to get feedback. We are here. We can spend time with you guys. We want to learn from you guys every step of the way. So if you have questions, if you want to spend one-on-one time, you just get in touch. So I'm Jason at flow.gl, and Bill is Bill at flow.gl. And you guys probably know that we're not an old, boring, big company. We are a small, active startup, and with a product that we think is going to help change the world, but we know that we're still building it every day and want your feedback in how it gets built. So what I'm going to do to the agenda for today is to walk through some of the new data we've got from NASA and other organizations on climate change. So we've got updated data for 2022, and what does that mean? I have kind of my own interesting angle on it, but I will say I am not a climate scientist. So if I have any of my conclusions are wrong or unscientific, either call me out or forgive me. But I think I have done a lot of reading, so hopefully I'm not too far off. Anybody want to jump in and introduce themselves, show anything they've been working on? Let's take a few minutes to say hello, and I'm just totally open.
Hello, Martin Bonny, based in Geneva in Switzerland, enjoying playing with Flow and learning more and trying to visualize everything with Flow.
And Martin is awesome, of course. He's one of our certified flow designers, and he actually built the messy flow, which Michael presented because he's got a larger audience on TikTok, and ended up, I think we're over 9 million views on that, which if you haven't seen the messy flow, I'll maybe pull it up a little bit later in the meeting today. But in any way, it was a really great example of what you can do with Flow, showing every goal that Messi has kicked in his professional career, shown across, in augmented reality, shown across a goal, so we can see where those goals were made.
Actually, a big fan of this Flow, and it's quite fun to see that I'm the second Martin in the audience, and I'm not from Geneva, I'm from Lausanne, so not very far away from the actual Martin one. And I'm here just because I've seen this Flow, and this is what introduced me to Flow, and I'm really happy to share with Martin and Michael.
Right. Thank you, Martin. Let me dig in. I'm going to start off just sharing behind my screen like this, but it may be just a little fuzzy, so I'll switch to a full screen share in a little bit. I can spotlight myself. There we go. So what I like to do is actually build out something that looks like this flow. And what we're doing here, we're taking a look at temperature anomaly. So how different has the temperature been lately versus a baseline? The baseline in our case is global temperatures between the year 1900 and 1980 or 85. I'm not sure where the cutoff was. I'll double check that. Let me admit Ahan here. And so this is one of these, is the first one here. This is the land temperatures and the ocean temperatures over time, seeing the delta from norms. We're going to take a look at how to build that. This is one that people who follow Flow have already seen a fair amount, but it is updated with the latest data. And some of those data points are just, I think they're actually kind of astonishing. So first of all, what's nice about this graphic is that from any angle, you basically see the curve by season of changes in the climate. And really the big changes are here in the winter months, November, December, January. This, some of these numbers, 2.6 degrees, this is Celsius, or 2.2 degrees in 2015, 2016, which was one of the warmest years on record. Those are just really, really standout numbers. So very interesting view. I'll show you how we build that in a moment. The next step to look at is basically the temperature difference between land and sea temperatures over time. Again, going from 1880 to 2022, and you can really see how the big effects are on the land. I could argue that the sea temperature changes are even more scary, because that's what drives weather. And we're going to actually talk a lot about that and El Nino and the Southern Oscillation today, because I think that's a really interesting way of looking at the data. So instead of trying to say, hey, this is the best visualization we've ever created, I'm going to say these are a variety of ways we can look at the data and start from here. In a couple of steps, we'll get to what I think is a better view. In this case, looking at this, the lines and area chart, this is the temperature of the ocean off of South America. This is where El Nino and La Nina actually occur. That whole oscillation is called the Southern Oscillation. You can see that going back to 1950s, where the data starts, you see these waves. El Nino are the peaks on top, La Nina are the lows on bottom. And those lows are, the temperature is anywhere from between -2 degrees Celsius up to 2.5 degrees Celsius swing. So you get a 5 degree Celsius swing in temperature. What is that? 12 degrees Fahrenheit drives a lot of weather. In this example, we've transposed it on top of the data, just the climate change data. It looks like I was messing with the colors and it kind of got ugly there. So let's not get too caught up in that. Yeah, okay, there's a couple of steps here, but we are going to answer one of those big questions. What was 2020? Was it the hottest year? And these couple of visualizations here by looking at the hottest temperatures by month, we can actually see that a lot of the hottest temperatures were back in 2016, 2017, some in 2020, but not in 2022. And we'll talk about what that means and how El Nino may have a huge impact on that. All right, thank you, Julian, on your comment on the 3D.
Oh, we lost him.
He hung up.
Oh, I don't know. He has Starlink and so do I, and Starlink has been really sucky for the last 2 to 3 weeks.
Yeah,
Okay.
yeah, he lives in an area that's had a lot of really pretty fierce weather the last few weeks.
Oh, it's not just weather related.
Yeah, he'll be back.
Starlink's been a piece of crap for the last 2 to 3 weeks. So
Yeah, I know. Jason oscillates. Sometimes he's on Starlink, sometimes he's on his land net. But I'm sure he'll be back in a couple seconds. There we go.
Got it. I guess my internet went away. Hopefully, how long was I gone?
Oh,
20
maybe a
minutes.
minute.
Sorry about that. And it's not even raining. Okay. Let's build some flow here. So when you create, first of all, questions or anything, things that I might have missed that because of my internet gap there, any comments or questions before I launch in here?
No, we were just musing as to what happened to your Starlink or whatever.
My Starlink is dead. I'm on my old internet connections. Starlink can be good, but it also can be a pain. So let's build this out step by step. So when you first create a flow, it's going to pop up this window, which gives you a set of templates, which is our new and exciting mechanism for looking at for getting you quickly from 0 to 60. So let's go ahead and start. One of those visualizations was a 3D radar chart. Now we're going to get lucky here and maybe a little unfair because this 3D radar chart actually uses climate data from 2 years ago. But let's go ahead and update the data with current data. So let's walk you through that process. Click replace data. What I've done is I've spent some time gathering this data, and I can share both this spreadsheet, but also the sources of the data. And I'm going to take a moment to talk about that. So I've put together 2 data sets into a single view here. I've got the temperature data, which is like the anomaly, which means delta from norm, of land temperatures of the northern hemisphere on land, northern hemisphere land and ocean, and southern hemisphere land and ocean. I actually focused, yeah, it's either global or northern, so this hemisphere column doesn't always apply. And the data, it took a little digging actually to get the data. Last Thursday, NASA and NOAA released the latest data sets, and this is the place to find them here. And I'm going to gather up all these websites and make sure and share them with you. But since this one is kind of the most important one, I'm just going to put it into this chat window. The nice thing about this is you can actually go ahead and decide what you would like to see. Do you want to see all months? Do you want to see global, southern, etc.? Once you make a few selections, you can actually download it as a CSV. And that is quite helpful. So that's where the temperature data came from. And I actually just did 4 different queries in order to get these 4 different columns. The El Nino data came from here, and it was a little bit of a pain actually to work this. So this spreadsheet, they ended up showing it here in this kind of weird table, and I literally just copied and pasted the table, unpivoted it, made it long so that each cell was its own row, which is an important step, data processing step to do in Excel or Google Sheets. And the way they, indicated whether this was a weak El Nino or moderate El Nino, just with one indication per year. And anyway, it took a little bit of playing in order to get that worked out for me to be able to label each month. And even each month labeling that is a little bit of a misnomer. So this is a strong El Nino here, but in fact, here, let me zoom in a little bit, make it a little bit bigger. But the strong El Nino is for the months of March, April, May, not a specific month, because it's the average over a period of months that decides where you are in that oscillation, in the southern oscillation. So once I had that correlated, now I've got this data set, which is my master data set. You can just grab the URL, paste it in here, and import it from a Google Sheet. And it's going to import that data. Now, based on how similar the data is from view to view, we automatically remap the data that was present in the original template and use the new columns. And you can see we did a pretty good job. It saw the old one column was called temperature anomaly. It went ahead and picked the first metric that it thought made sense. And here, we're still in a fully interactive environment, we can actually go ahead and swap those columns. Now, what's kind of nice here is not only does it tell us what the data was, what new data we're using, but also gives us a quick access into that data. So we can say, hey, the depth axis, click on it here, it takes us right to the year. We get a nice little flashing thing. What colors are we using? Oh, the column anomaly global land temperature is used for the gradient scale on the colors. So it's a really handy way to be able to figure out where the data is getting used in the spreadsheet. So first step is complete. Let's move on and add another step and look at the data in a different view. So let me remind myself on what. Oh, here, slightly different data set to generate these views. And so let me build that out. I'm going to use the same chart, but because it's going to be a different data set, I am going to want to create a new swarm, we call it, or new visualization. And just to be clear, each one of these visualizations is a swarm. That's our custom name for these things. Think of it as a chart. Really what it is, it's a way to arrange dots in 3D space based on data. So I started with the exact same template. And this time I'm going to replace the data with a CSV file, which is annual temperatures instead of monthly temperatures. And again, it's going to pop up the view here and see how it maps. So it mapped from month to lowest smoothing. Yeah, that's not going to quite make sense. So equator angle offset. I think this is also probably going to, no, that's not correct. Let's go here to year and see how that works. Okay, so it actually did the right thing. It's each year is being shown here. We can spin it around and see the angle. The farther you are from the center point, the greater the temperature. I think the connection lines are a little, connecting in a kind of strange way. It's trying to connect lines year to year, and it's also showing both actually what it's showing is the delta between the sea temperature and the land temperature. Let's show the lines a slightly different way. Actually draw the lines to the center point, to the axis, with the level at 0. And to fix this up, because it's showing 2 data points, both land and sea. Here, let me show you the data. This is the new data manager pop-up releasing this week, which we're kind of happy with. Brings all your data in a single place. You can see your data sources, get those handy. You can see the data preview. You can work on your data transformations and re-upload the data should you when you want to do that. So the data we have here actually has a column land or sea. And that's why we've got 2 data points. We've got this data point here and that data point there. And so I'm just going to filter those out. So we've got one at a time. So I'm going to show this row when the land or sea contains land. And now that I've got that, I'm going to just do a few other tweaks. I want, because my data set has an axis, on either side of 0, the numbers go from a positive to a negative. I want to make sure that I'm setting a couple of things around the 0 point. Now, I know I'm bouncing around a fair amount, and I'm sorry for that, but this does give you a quick sense of building a pretty sophisticated visualization using a template pretty quickly. One of the things that I would like to do next, I think, is there's just too many labels. It's complicated. Here in our components area, here's a new feature as well. So did you see this little configuration incomplete flasher? That's a really handy way. It is a button, and it jumps you to any point in flow where you might be getting stuck because something isn't set that needs to be set. So on the labels, we want to show the labels when the value of the column temperature is the maximum for, it looks like I can choose either land or sea. Actually, what I like to do is I'd like to show the column when the year is maybe greater than 2020. So that's, and I don't want to limit to a random subset. And I'm surprised, oh, greater than 2020 is only picking, I'm sorry. This data set that I brought in actually only goes to 2020. So my mistake there, greater than 2018, maybe? Okay, let's see what's, so it's just picking a couple of maximums. I'm not sure why exactly. I've only got a few data points here at the end of the view. Grab a few more greater than 2010, things like that. Okay, so you've got a sophisticated way to do that, to work with your logic on showing what labels are where. And let's proceed. Going to add another step. Now, just to remind you, right, this is a multi-step environment. So it goes from step to step as you navigate, as you create these. And that's where, step by step is how we tell a story. Okay, what's our next view here? Just being able to see land and sea in this kind of view, that's a really easy visualization to create. I'm going to go back to that first swarm because it's going to be the same data set. I can reuse that swarm and get a nice animation by doing so. So we have a new button, new visualization from template. We're going to take that same data set, same swarm, and add in a new way of looking at it. So here we are. Just make sure that. So what it did is it just grabbed the data, and because the data was so similar, it didn't need to do a very sophisticated remapping. It went ahead and picked a couple of things, and we can see here. So this data set to columns, this is kind of a magic overview of what data is being, what columns are being mapped where. It's a similar view to the remap that I was showing you before. So I don't really want to color it by hemisphere. I would rather color it by temperature. And the connection categories are a little bit confusing here. Instead of doing it when columns match. So right now it's trying to show something when the columns match a certain temperature. That's actually nonsensical. You could have it match year. So since this is monthly data, you can see that each line is made up with a bunch of matching years. But in this case, I think what I want to do is just drop the lines down to the axis. And that will make the most sense. Other thing you notice is the colors are kind of crazy. But even before we get to working on the colors, let's work on the chart. So obviously what we've got the year, and we've got the temperature data here. So we're already getting pretty close. But the colors are crazy insane. Here's another new feature as of today. You can click on this dot next to any expandable section and collapse all the other sections. Really handy way to clean up your view. So for the instead of colorizing it by a color scheme, we actually want to colorize it by a gradient scale. Let's make the colder temperatures a bright blue and the warmer temperatures a red. And we're getting a little bit of flashing here. And that's because, I don't know if you can kind of see the way these lines are wiggling. That's because we've got two data sets on top of each other. And now we get to use the third dimension. So as we add the depth axis, we can go ahead and use, oh, this isn't the same data set I was thinking. I thought I was working with. I should have been working with the annual data set instead of this one. So my mistake there. I was going to split that between land and sea, But we can still, I think we only have the one hemisphere data here. Let's take a look at it in a different view entirely. So one of the things I've done with this data set is I've added what's going on with El Niños. And so now, instead of just looking at the data going entirely in one scale, I've recategorized it so we can see the relationship to El Niños. It's not exactly the view I was going to build. So this was the annual data, and I'm going to skip that. So instead, I'm getting more towards this view, which is going to show the ENSO, the Southern Oscillation data on top of the main other view. So let's work with this a little bit more to create that. And turn off the depth axis and just have the single view of the temperature anomaly data. Since my data is zero based, meaning that it's got negatives and positives, a little bit easier to see it in this view. And when you have a view, a timeline like this, depending on how high and tall the data is, it can be better to reduce the height a little bit to give it a little bit different aspect ratio. It's easier to see certainly on this kind of a screen. If you knew you were building it for a phone, maybe you wouldn't want to make it wide. You'd like to keep it tall. So sometimes knowing your audience and what you're working towards is important. Okay, so that's our standard background data, right? We wanted to get that background view. Ignore all the weird colors there. Now let's show the oscillation data. I'm going to create a new visualization. And the closest one is probably, let's try the 3D time chart. And we're going to, in this case, I'm going to select data that's already in the app. So let's just go ahead and select temperature data. And right away, as soon as I selected that, it didn't know what to do with all those columns because it's a totally different data set. So let's go ahead and pick those out. So across this, we want across the horizontal, we want the date. On the height, we're going to use the ONI, which is the oscillation data. And we actually don't need a depth here. It's telling us incomplete. What else do I need to do in order to get this to work all the way? We'll use the ONI data as to scale the sizes and the ONI data to scale this, but it's actually doing a color scheme. Let's do a gradient. And let's go, similar to last time, let's go to red. And sure, green is good. Okay, so it's only has data from 1950, and it also, we want to make it line up with the other one in terms of height and width. So 1.5, oops, 1.5 on the width, and the height 0.6. And so now we can see that got the same basic data mapped on the same space. I don't really think I need to scale the value, scale the sizes. I'm going to turn that off and make it fixed. And it's got an area chart. Oh, it doesn't know how to deal with the area chart yet, but we can just fix that. And row order is fine. So now we've got two data sets on top of each other, and we want to see how do they relate to each other? Well, it's actually pretty hard to see. Not great. And I knew it was going to look that way because I've been working with this data for a while. So as opposed to say, hey, this is the final step we would show an end user, let's just go ahead and see if there's another way we can view this data, which might be really interesting and powerful. I'm going to turn off one swarm and just work with this guy. And here we can maybe use that third dimension, right? This is a 3D scatter plot, and we want to see ONI data or the oscillation data on top of our other view. Okay, it's hard to see what's going on here, but we can solve that. Clean up that. Okay, so first, I'm just going to remove this labels object for the moment, so we don't have to fix that, but it was nice that it told me that it was broken. So we've got drop lines. I'm going to add another connections object in order to just show the line over time connecting these guys. Okay, so that's kind of an interesting, we're starting to see some relationships here. Let's add an area chart. And I'm also going to do it in row order. Oh, there's some sort of structure showing up here. They're getting interesting. Let's clean this up. First of all, we only have data from 1950. So we can go ahead and filter out the data before 1950. I should say for the ENSO, we only have data from before 1950. So just go to the filter, create a new filter, and show when the year is greater than 1950. All right, that's starting to look like an interesting data structure. Let's see what we're looking at here just for a moment. So looks like some of the axes aren't really showing up yet, but let's just identify, let me just tell you what we're looking at. So obviously we've got time from 1950 to 2020. The height is the temperature anomaly. So how warm was it? And on this axis, we're looking at the temperature of the southern oceans. And you can see those, remember those waves of looking from the top down, you can see those waves of El Niños are up here and La Niñas are down here. In fact, what I want to do is, right now we're colorizing the data based on temperature. And I'm going to colorize it based on ONI. So now we already have the height to tell us the temperature. Now we're looking at the color based on the temperature of the ocean. And we can start to see these relationships, right? And here we're going to get into the real heart of this data. So bear with me. What you can see is that when there's a El Nino, you get the warmest temperatures of history. And these last few years, even though the temperature has been very warm, we have not had an El Nino. In fact, we've had 6 years of La Nina, the reverse of that. And it's a pretty deep La Nina too. Look at how high in this view, how high that is. Remember, El Ninos are close to us and La Ninas are far away from us. So we've had a long stretch of La Nina. In fact, it's the longest they've ever measured. You can tell, look at each one of these peaks in the past corresponded to El Ninos, especially in 2016, which is the warmest year in history so far. The fact that we had such a warm year, despite the fact that there was no El Nino, that is the big, scary elephant in the room. So I've been seeing a lot of scientists, a lot of documents on this, including pretty big articles in the New York Times and Guardian the last 2 or 3 days saying, take a look at this. Why is it that we've had a huge temperatures, even though we've got cold temperatures in the southern oceans? And as cold temperatures, I mean, 1.5 degrees Celsius cooler than normal. And if strong El Ninos show up with 2.5 degrees warmer, what happens this year, next year, when we get an El Nino and we have this overall curve of rising temperatures? And that is the big question that scientists are looking at, and maybe the big story of the next couple of years, and why they're predicting that 2023 and certainly 2024 will be new records. I will stop there. Questions, ideas, and comments? First of all, did it make sense? Seen a couple of nods.
Yeah, actually, you can see the pattern increasing, right? And that's kind of a curve that later on you can use to make predictions, right? So
To see
probably
both-
yes, you
Use
can
it to
see.
make predictions.
Yeah, you can see it repeating itself. It's really cool. Thanks for going through the whole process, because it's really nice to see how you create and how you got to this last visualization. Is really interesting. Thank you.
First time I've explained it, and as you know, the more you explain something, the better you get at it. So as well as continue to refine the visualizations. To kind of finish off the this process here, obviously I can click present and see it full screen. I can also share it and go ahead and make it shareable. And as soon as I do so, it's actually live and public on the web. There are a couple of tweaks to the app that were done last night. So I am running locally off my local server. We should have a build later today that will, so it can be public and everyone can be able to see this view. Okay, thank you, Kathleen. Losing me, is my internet bogging down again?
No.
Great. Okay. I'm going to stop sharing, and now this is really time for you guys to maybe show some of the things you've been working on or thinking about, or ask any other questions you've got, and really appreciate what you guys are thinking about. So, Julian, how are things going with you?
Well, I'm still on sketching phases, but it's really interesting to see how you're creating new things well, I probably will try to do some things about climate change this next week. So, and actually, well, there are two things. One is really simple. I was thinking about land and sea and how you use the chloroplast this to paint and show different scales, right, of colors. And I was thinking if we can use it to create different kinds of mappings, right? So I can use it to paint to the ocean as well. Today, I understand that we have a map that comes with Flow already, but I don't think we can select these kinds of parts. I don't know. Makes sense.
Good point. I don't think we have any maps that are designed to show ocean temperatures or ocean data. The closest thing to that is to get a grid of data and map that onto a gridded, XY lat long kind of view. So let me show you the closest thing we have to that. I considered working on that, but a lot of the gridded data is very high resolution. And I personally don't have a really handy way to map it down to a lower resolution view. Michael has done more work on that, so maybe if Michael wants to mention it. But here is an example of actually putting a dot on every lat long and then colorize those dots, and that is essentially the heat map. So yeah, we'll pull in this view. And of course, those lat longs would also include oceans and ocean temperatures. So if you go to views like this, global maps, and try to pull down data with the right level of detail, you will be able to generate these kinds of views. I'll have to
Okay, yeah.
take that as a future training session.
Yeah, no, but it's interesting also to understand as a really high level, right, high resolution way of seeing it, but also it's interesting to think in a really simple way, because we could create different or simplified versions of maps, or even more abstract ways of showing. So I can draw a shape and kind of use it to paint and see it as rising or low in colors. So maybe that's something that could create a different way of seeing, right? Of showing those charts. You know, maybe that's something for to think about.
There is a way to take basically one of the things that we've been experimenting with, and example that we just used actually at CES was taking a logo, turning it into a 3D model, and then mapping dots on top of that. So in that case, it was nice because all of you looking at all your data, and then all that data comes together into a logo, or it comes into a shape of a woman holding a baby, or it's a very nice way to take data and make it human. We have a couple of new techniques to do that that are in the product. Is actually if I share my screen again. There's something called Mesh Surface. And right now it's in alpha, so it's not available to all our users, but I think we can take it out of alpha. It seems to be working pretty well. Essentially what that does is you upload a 3D model, and then it puts dots all over the surfaces on that 3D model. And it's a really beautiful way to accomplish just exactly what you want there. And it's pretty easy to find, find or create 3D models. So that's not exactly a map kind of thing. And not sure, that's probably a big tangent from what you had in your mind, but I'll mention it as interesting way.
You can use to create well, if you cannot load 3D models, you can use it for bringing maps as well. So you know.
Sorry, it looks so creepy here. The sun came out and it's shining directly in my face and view here. I was not expecting that after all these weeks. So I'm a little creepy, and I don't have a curtain over that window, so forgive me there. Greg, it's been a while since we've seen the tool.
Yes, looks awesome. I've got my hands on a plethora of data on the decline of creativity.
Oh, wow.
And there's actually a few swarms that I'm going to need to build with it and use in my presentation. So we're at a pretty chronic state right now. And so I assume that if I were going to walk people through, I don't know all the terminology in the app, but if I have several sets of data that I want to layer, so you can see the relationship of all these things, but then I want to, remove one or two, I would just duplicate that swarm and then just delete one, almost kind of like doing a slide presentation. Or
yeah, so it's the timeline, which I didn't really describe in too much detail, is exactly how you do that. So you can see that each, the yellow dots here, the yellow boxes are swarms, and you can, so you can see where those are made visible or invisible across steps. Right. And even here, so I'm on step 2. If I want to make this swarm visible, I can click the icon or double click it, and now that swarm dots become visible. And same is true for each of the connections and labels and area charts. And then same thing with maps, images, text, models, etc. Each one of those. So you make them visible and invisible across the steps. And then any particular swarm, if it's using a swarm, has to use a single data set. You can't swap data sets in a swarm, but because I'm using a single swarm across 2 steps with a different visualization, it animates into place. And that different thing is called a perspective. You can actually see that on step 4, it's using perspective 2, and on step 3, it's using perspective 1. I didn't have to create those. It created them automatically for me, but it's kind of nice to know that that's how it does it. A swarm goes through steps and may or may not change perspective on each step, and it may or may not be visible on each step. And you can have any number of swarms visible or invisible on each step.
Okay, great. Cool.
So for folks who don't know, Greg was actually in the room when we founded Flow and was a co-founder. He left the company after 2 years to go do other creative things and work on his book and his consulting work. But Greg is original Flow OG.
Right. Yep.
Still,
Good times.
we had fun. He still has some stock. So his founding stock hopefully someday will be worth something.
Yeah, that'd be
amazing.
awesome if it was. You guys are doing great. I'm proud of you. Really good.
Thank you, sir.
And
Kathleen, I'm interested in your experience with Flow and what you're thinking of using it for, and anything you'd like to share. And if you wouldn't like to
Well-
share, that's fair too.
Well, I'm a librarian, a high school librarian, and I'm very interested in AR, VR, and I look at the data sets you just used, and I've used those for, have you heard of Science on a Sphere?
No, good name though.
So, yeah, they use those data sets for Science on a Sphere to project it onto a globe. Some people have seen Science on a Sphere in museums and stuff.
Oh, sure. Like actually, California Academy of Sciences. No, where? Oh, Exploratorium. Yeah, I've definitely seen.
Yeah. Yes, I'm sure the Exploratorium has one.
Mhm.
But I kind of built a miniature one in one of my back rooms for the teachers and stuff to use.
Oh, wow.
So it reminds me of using kind of that sort of thing as well. So I'm brand new here, and your timelines remind me of different things that we've done with video pieces
Sure.
and being able to show, and there's a lot of transferable skills I see in with your interface. So I'm excited to learn. I'm excited to learn more. Does that give you enough info?
That's
Well,
great.
I'm in entirely over my head, but that's usually the case when I learn something new. So, because in my library, I'm also in charge of the 3D printers, the laser printers, all the sound and video production. And I do all the sound and video production for a lot of the programs here. So
Wow.
I have to do a lot of things. I have to know a little bit about a lot of things. Put it that way.
I love the idea of librarian as arbiter and communicator of digital information and the future of.
Well, that's what we do. I mean, I'm in charge of 1,300 Chromebooks and
Oh my gosh.
and putting all that together and still maintaining a selection of stacks of actual books and things like that. And we've done a lot with the AR and the VR stuff, and just trying to branch out more. And one of the last, it's kind of interesting in my field of work, one of the last people to actually adopt a lot of these techniques and a lot of this technologies is actually math. I have the hardest time getting into my math teachers.
Really?
It sounds counterintuitive, but they don't want anything to do with it. So it drives me up a wall. English teachers, social studies teachers will take on tech. PE teachers will take on tech before math teachers will. So it's very, very interesting.
why do you think that is?
I don't know. I truly don't know. Well, maybe it goes back to, well, I remember when, I don't know your age, but my age, when calculators everything else, and they go, oh my God, if there's a calculator, they're never gonna learn how to do X. They're never gonna, oh my God, is there gonna be a day you're gonna have a calculator in your pocket? Well, yeah, there is now. So, well,
Yeah, well, just my age is that we weren't allowed to use calculators, and the first scientific reverse Polish notation calculator that came out was about $250. I bought one, but I was threatened within inches of my life of bringing it into the classroom.
It's crazy. It's really crazy. Now, I think back, I did not do real well in math in when I was growing up, but having the tools that I have now, it's it helps me quite a bit. I mean, no one would know that. They all think that I'm a math whiz. I'm like, no. It's just because the different tools that now that we have that are available to us that are helpful.
Well, they have some insight into one of the reasons why creativity is in the decline, because of we're seeing 6 forces that are converging in strengths that we've never seen before in history, and one of them is just-in-time learning. And
What is your name? I'm sorry.
Greg Moyer.
Yeah, I'm very interested in that as well, because the big push in education is to how can we get our kids to like critically think and everything else. And it's like, well, duh, you've been telling them the answer since they were in 2nd grade with all the
Pretty much.
with all the stuff that they do. They don't want to try. They don't want to try. They don't want, like, the A kids. The A kids are the worst. The A kids.
There's other factors as well. It's actually what I'm going to be charting with Flow. I've been amassing, I wouldn't call it critical data per se, but data from research from MIT and Harvard and Stanford. They've been doing the most work on this, on the decline of creativity, and then there's other researchers over the last 20, 30, 40 years that have done the same thing, and they've been sounding the alarms and no one's paying attention. So
to give you, this is very close to my heart, Kathleen. So I actually took 2 years out of my high-tech career and started a K-8 charter Montessori school. Wrote the charter, got the charter approved, opened the school with 120 students. Purchased a 35-acre site and built it out. It was quite the adventure, as you can imagine. But really thinking about, in our case, it was Montessori with project-based learning. How can you get kids engaged? And the Montessori piece was so manipulative. It was so 3D. Now I know when you take something, you can turn it around in your mind or physically, it helps it stick in a very different way. And how can technology, and in this case, AR, VR, or even just 3D on a flat screen, how can we really help people learn those skills, get better mental models of it? And education is a fabulously interesting space for us at Flow. So I'm really interested in what you're discovering and what you're learning, and ways that we can, like I say, we want to gain insights from your insights on how Flow works or doesn't work. And maybe some of those statistics, and start with the statistics courses, maybe be able to get some of those math teachers to understand that
it's
making concepts more concrete in your mind is vital to their subject.
And I don't know if it's they don't want to, it's something new, so they don't, and they're also never used to failing because they're good at it. And kids who don't do real well at math, they have a hard time. Well, how come you don't get this? Well, because I don't. So they don't. That's hard. That's hard for them. That's a big.
It's a risky thing.
It's a big risky thing, and being creative is a really risky thing. And it's because you can't grade that. That doesn't show up on standardized tests. So that's, I think they're on your opposite ends of the spectrum.
Got it. Well, we have you, as they say on Car Talk, you have all burned a whole very valuable hour with us. Thank you very much.
Yep.
And do feel free to reach out to me directly. You guys already know that, Jason at flow.gl. But everyone, I'm just so glad to have you on this journey, and let's go help the world solve some important problems.
Excellent. Thank you.
I just sent you, I'm sorry, your first name again,
Kathleen.
Kathleen. I just sent you my email.
Oh, how wonderful. Thank you.
Well, sure.
Grab that out of the chat, because it'll disappear when I end the meeting in a moment.
Yeah, that's why, that's why I said something. So-
Here, well,
Thanks, Martine, Solomon. Pleasure to have you with us
Thank you.
today.
You too.
See you guys soon.
See you. Bye.
See you next week. Yeah, bye all.
Thanks, Jason.
Thanks.